I remember the hush of laboratories at night, the soft refrigeration of machines, the glow of cathode ray tubes turning green in the dark, the dull thud of magnetic tapes coiling and uncoiling like the breathing of some enormous mechanical animal. Outside, the world was taut with a Cold War urgency: maps, commands, contingencies. Inside, a handful of researchers were tending to something smaller and stranger, a design sketched in a different kind of urgency, not to detonate or to destroy, but to link, to distribute, to make information survive. That was the late 1960s, when the U.S. Department of Defense's Advanced Research Projects Agency quietly funded experiments that would outgrow their brief. The idea came from a few intersecting anxieties and ambitions. Engineers worried about the vulnerability of centralized systems under the specter of nuclear strikes. Theorists imagined communications that could be sliced into packets and rerouted, resilient and efficient. And above all, there were dreamers, like a psychologist turned computer man, who years earlier had written about a galactic network, a vision of many bodies of knowledge accessible from anywhere, a kind of collective mind made real by wires and code. In a universe of punched cards and paper printouts, this was a new grammar. Messages not in one long circuit, but broken into small parcels, sent independently and reassembled at the other end. Packet switching would be the hidden choreography. It was elegant and practical, a way of building a communication system that could bend around damage and congestion rather than collapse under it. The architects sketched protocols, tested routes, and argued for a future in which machines could speak to each other across distance, as sailors exchange messages across oceans. On an ordinary night in late October 1969, the faintest human gesture marked that turning point. In a campus lab, a graduate student touched a key and sent the first deliberate command across a fledgling network connecting distant research computers. The intent was simple and almost ceremonial: a login. The command began to travel through apparatuses the size of wardrobes, through interface machines that translated between computers and the new packet network. The receiving system answered, but with a wobble. The software could not keep pace with the novelty of being connected. The system hung after 2 letters. The first message across the world's first wide-area computer network read, modestly and pointedly, "LO." It is a small human moment, 2 letters that mark the collision of curiosity and failure. It is also the hinge of a story that would not stay small. Those 2 letters were typed by a person inside a university room. The significance emerged only later, as more labs across more campuses and research centers plugged in one by one. Interface message processors sat like guardians on the network's perimeter, built by a small company working under contract, translating local computer talk into packetized conversation. Universities that had once competed for scarce compute cycles began to share, to route, to depend on one another's machines to run experiments and exchange results. A secretive, military-funded scaffold proved to be an effective incubator for a public culture of exchange. The technical story that followed is a sequence of refinements, disputes, and breakthroughs, but it reads like an expanding landscape. Email arrived and quickly became a lingua franca. It was less a planned feature than an emergent use, a human habit that took hold and spread faster than the designers expected. Where the network was supposed to be an instrument for sharing research, it became a way to talk, to circulate jokes and ideas, to create communities that did not require proximity. Protocols multiplied, each a small contract about how machines should ask, answer, and confirm. Names were bound to numbers. Systems to translate addresses into human-readable forms were designed as the network grew beyond the ability of people to memorize raw routes. Someone had to stitch together a way for different networks, built by different teams for different purposes, to interoperate. The solution was to invent a universal language for packets, a layered architecture where reliability and addressing could be separated from the messy details of underlying links. That architecture, the work of engineers who sketched out a transmission control protocol and an internet protocol, let islands become a true sea. In a decisive switch of the early 1980s, the nascent network adopted this common language, and connections that once required bespoke engineering now negotiated a shared grammar. It was a quiet revolution, an agreed protocol, a common handshake that allowed networks to scale without collapsing into chaos. From laboratories to laboratories to laboratories, it spread, and then outward. National science foundations and research institutes connected with their own backbones. The network that had been a series of experimental links became an infrastructure. Routers and cables, naming systems and routing tables, servers that hummed in climate-controlled rooms. The dot on a map where a cable landed became as strategically important as a depot or a pier. What had been a military research initiative began to carry not just experimental data, but commerce, culture, and conversation. Parallel to the growth of pipes and protocols, another invention quietly reframed what the network could be. The web was not the internet itself, but a layer of documents and links and a simple way to tie them together. It introduced a metaphor the public could grasp, pages and links, and made navigation an act any person could perform. A browser turned that abstract infrastructure into a place. A single line of code could, within a decade, transform a network of research machines into a garden, a marketplace, an archive, and a platform for politics. The human consequences unfolded with a speed that surprised even its most enthusiastic engineers. Economies reoriented around instantaneous information flows. News traveled differently. Markets reacted differently. Commerce found new geographies. People made friendships, formed movements, and organized protests without the constraints of localized bulletin boards. Art, once constrained by physical proximity and slow reproduction, found new mediums and new audiences. At the same time, power shifted in subtle and not so subtle ways. Companies that controlled access and searched the flows became gatekeepers. States learned how to surveil and censor in the language of packets. Malicious actors discovered that the same openness that enabled collaboration also enabled new forms of theft and propaganda. Through these changes, the network retained a paradox. It is at once utterly visible and almost invisible. We see its effects everywhere. The delivery truck that uses a routing algorithm, the video that buffers on a screen, the news alert that lights up a phone at dawn, but we rarely see the physical labor of cables and cooling systems, the policy debates, the engineers fixing obscure routing loops at 3 in the morning. Its centrifugal growth has made it essential, and its essentialness has made us vulnerable. Dependence on invisible infrastructure means that small failures can ripple widely. A broken undersea cable can mute an entire region. A misconfigured router can reroute trust. And yet, beyond the vulnerability, there is an enduring lesson in that first LO. The moment was not a dramatic coup or a triumphal unveiling. It was a modest test, an attempted login from one machine to another, a collision of aspiration and the stubbornness of early software. From that unrehearsed glitch grew a world in which millions of people log in every day, not simply to input credentials, but to step into a shared space of knowledge and action. What follows is not a tale of inevitable progress. It is a story of choices and of emergent behaviors. Technical standards were crafted in meeting rooms and on mailing lists. Legal frameworks were written in courtrooms and parliaments. Cultural norms were forged in communities, often in tension with economic and political pressures. Each choice shaped who could speak and who could be heard, whose data would be protected and whose would be harvested, who would have access and who would be excluded. The internet's architecture offered equal opportunity pathways, but human institutions have repeatedly rerouted those pathways. Today, the world is stitched together in a way that would have seemed allegorical to those first researchers. A child in one hemisphere can watch a teacher in another. A scientist can collaborate in real time with colleagues thousands of miles away. Dissenting voices can find audiences and quicken political change. The same infrastructure amplifies disinformation and enables surveillance. The distributed resilience that packet switching promised coexists with centralization. Clouds of computation concentrated in far-flung but discrete facilities, platforms that aggregate attention and power. As I look back further, the significance of a login extends beyond the technicalities. It is an emblem of connection, of the impulse to reach out, to extend a line and wait for a reply. The internet is a tool that mirrors our best and worst impulses. It lowers barriers and raises stakes. It offers a public square that can be enlivened one moment and poisoned the next. It gives voice and, in some cases, strips it. It holds archives of human achievement and repositories of deception. This is the quiet, continuous urgency of our time, to steward an infrastructure that is more than cables and code, to build systems that are robust and equitable, that protect privacy without smothering innovation, that support flourishing communities without concentrating power in the hands of a few. Technical fixes alone will not suffice. The governance of shared resources requires civic imagination and political will, new norms and new laws, an ethical infrastructure as deliberate as the physical one. There is a final small image I return to. A fingertip pressing a key, two letters appearing on a screen, a sound, the soft mechanical clack of a moment that would be replayed billions of times in languages and scripts the originators never imagined. That movement, the act of reaching across distance, of initiating a conversation, is the kernel of what it means to be online. The day the world went online did not happen in a single instant. It happened in 1,000 incremental gestures, in software patches and new cables, in late-night hacking sessions and policy debates, in the way a child learns to send their first message. Each gesture carried a choice about what the network should be. We are living with those choices now. The question before us is not whether the network will shape the future. It already has, but how we will shape the network in return. In the end, the simplest act, to log in, asks us the oldest question: who will we be together when the world is a little more connected than it was yesterday?